So today's lesson is about trig graphs, and there'll be some connections also to trig equations that we were doing in the last lesson. But just to quickly put them up on the board, these are the basic trig graphs. So you can see the graph of y equals sine x to the left, y equals cos x, and y equals tan x. Now, being familiar with the basic properties, so things like the period of the sine graph is 360, the period of the cos graph is 360, but the period of the tan is 180. Those are basic facts that you're assumed to know, but you also need to be comfortable with what we call transformations. And so what type of transformation, I'll put this out to the group, would that transformation be? Who feels like they can tell me what that +1 is going to do to that sine graph? You can put your hand up or pop it in the chat. Yeah, it's just going to make the graph shift up. We call this a vertical shift. And so this sine graph would basically just look like that. Everything goes up by 1. Now you could also, draw the graph of y equals sine x minus 1, and that would just move down by 1 unit. So that's one transformation that you need to be aware of. Another transformation you need to be aware of is something like, let's make it cos y equals 2. What does that 2 do to the basic cos graph that I have here? Nice, Bongi, very well done. Fateko, nicely done. What does the 2 do in front of the cos x? Now you've got the basic cos x graph, but what about the 2? What does that do? So it's not a period change. Period change would be the number but in front of the x there, and at the moment that number is just 1. This is what we call an amplitude change, and it stretches the graph up or down. Actually, sorry, it's both up and down. And so instead of starting at 1, this would actually start up at 2, but it would also go all the way down to -2. So let me see if I can show you what this would look like. So it's almost like the graph has been stretched vertically. So that would be the graph of y equals 2 cos x. If you wanted to see the graph of, I can also do it on sine. Maybe it's a bit easier if I do it on sine. So y equals 2 sine x would just look like that. And that is called an amplitude change or amplitude stretch. Okay, so the number in front is that one. So that's something else we need to be aware of tonight as we go forward. Then also, what would happen if, let's stay with sine for now. I've got my basic sine graph. What would happen if I change that to y equals sine 2x? What type of change does the 2 make? Now the 2 is inside the input kind of area. What do you think that 2 does? So this is what Bongi was asking about a moment or two earlier. This is what's called a period change. So the old period of the sine graph is 360 degrees. You can see this because the graph takes 360 degrees to do a full cycle, up, down, down, up. The new period of the graph is going to be 360, the old period, divided by the number in front of the x, which is 2. So what is the new period of my transformed graph going to be? So it's going to be 180. So let's see what this graph would look like. Now, if the period is 180, then the quarters that I draw it in are going to be 180 divided by 445. So actually, the important bits for drawing this graph are going to be here, here, here. So let's see what it looks like. So it's going to go up to 1, then down. Let me try that again because that was a bit. So there's up to 1 in 45, down at 90, down and up. And what we notice is that a full period of the graph now fits in 180 degrees, whereas before I needed 360. And so that's what we call a period change. Give me a thumbs up if period change, you have some awareness of that. Okay, that's awesome. Then one last one we need to be aware of. And I'm just going to use sine because sine seems to be the easiest way to do this. What if I said to you, what is the graph of sine x minus 30? Now, that is not the same as a period change where the number in front changes in front of the x. It's slightly separate. What do we think that type of change to the basic sine graph will happen here? The new stuff is the minus 30. Okay, so this is called a horizontal shift. So horizontal shift. And it obviously shifts it by 30 degrees. But what's tricky is for minus 30, it actually shifts it 30 degrees to the right. So most students would expect, because there's a minus 30 here, it would go to the left. But horizontal shifts work in the opposite way. So I really want to emphasize that. So what would this graph look like? Basically, this point would move to here, and everything else would just change. So now that would be up there. That would be down there. That would be over there. And so let's just see what this looks like. So we're going to go and then it's going to look like that. And then here, it's going to look like that. So it's just 30 degrees out of sync. If you notice that, like, the gap is always just 30 degrees each time. This is called a horizontal shift. And so when we talk about the different types of transformations, they're often represented like this. Let's say K. So if you think about the A would be the amplitude change. This K would be the period change. The Q would be the horizontal shift. Sorry, the P would be the horizontal shift. The Q would be the vertical shift. And those are the 4 changes that you need to be aware of as we go forward tonight. And I'm going to show you them in questions, but I just wanted to actually give you a basic feel for that idea. Okay, let's do some basic multiple choice questions here. And then they'll ramp up to more difficult ones, but let's just get in the groove first. So what graph is this? I want you to identify. Okay, this is not very hard because of the fact that it looks nothing like the sine and cos graph. And so we would say the answer is C. What I want to point out is that this trig graph has asymptotes. These asymptotes occur every 180 degrees, like between 90 and 270 and so on. And trig graphs are a little bit different to sine and cos graphs. They have a different period. 180 is their default period. And they have areas of discontinuity or asymptotes. And so we have to be aware when drawing them where those asymptotes are. Okay, let's not, it's too easy. Let's do this one. Choose the correct answer to this one. A, B, C, or D. Yeah, so that is just a vertical shift, and the answer is going to be B. So that's good. I think everyone was happy. Oh, here's an interesting one. What effect does minus cos x have on a trig graph? Now, we haven't explicitly done this, but maybe you can work it out. So it's changing the y value from a positive to a negative. And so I want you to think about that. And while you think, I'm going to maybe draw something to help us, but you think about that for a bit. So if you imagine that what's the y value here? It's 1 for a normal cos graph. Now, if you put a minus sign in front of that, what would 1 become? It would become minus 1. If you put a minus sign in front of 0, you would just get that. If you take minus 1, which is down here, and you put a minus sign in front, you get that. And you get that, and you get that. So what this transformation does, okay, is you're just going to get this effect. Because it's gone from whatever y you had before, it changes to the opposite sign. So which one do we think is correct? Well, I think this gets reflected in the x-axis. If I look at it visually, it looks to me like everything gets reflected over the x-axis. So even though the sign in front of the y is changing, it's the opposite axis that is affected, which is a good rule of thumb. If you change the sign in front of one axis, it's the opposite, it's the other one that is going to be reflected over. So what is the correct answer now? Lock in your correct answer based on the drawing on the screen. So the correct answer is going to be A. It's reflected in the x-axis. Yeah. Okay. Let us do, not that one, not that one. Let's do this one. Which one do you think is going to work for? Which of the following gives the equation of the graph? I don't think it can be C or A or B, because those are horizontal shifts. And this to me looks like there's been a vertical shift. And it looks to me like the shape is the sine graph, but it's been shifted down. And so my answer would be A. Because you can imagine the normal sine graph looks like that. Okay, it should be more symmetrical. But if it looks like that, all that has happened in this graph is that that has moved down by 1 unit. And so A should be the correct answer. Bonus question. What is the range? What is the range of the green graph that you've got here? What is the range of the green graph that you have here? What do I talk about when I talk about the range of a trig graph? I'm talking about its y values. Who has some answers for me? You're on the right track, Bongi. So if you look at the y values, the highest value it gets to is 0. The lowest value it gets to is -2. So I would say that it should be greater than or equal to -2, and it should be less than or equal to 0. So that would be the range of this. Josh agrees too, yeah. So that's the range of this transformed sine graph. Okay, let's look at this question. Now, in this question, you are given a cos graph. So let me just point out how it starts at 1, and you are given, you have to recognize this is a cos graph. Well, actually, it shows you here, or kind of shows you. So I want you to think about, if it says cos x equals 0.64, and it wants to know what values of x will make that true between 0 and 360. Now notice how these axes are 0 to 360. Which of the 4 options do you think is correct for this multiple choice question? And some of you who were in the last lesson, you can think of this as a trig equation, can't you? So you could use the visual approach, or you could use some of the methods you have. Now, cos x is the graph, 0.64. Where would that be? That's a y value. So here's 0.45, 0.6. I guess 0.64 would be somewhere. So I want to know, when does the cos graph, the red graph, hit 0.64, symbolized by the green straight line? And it feels to me like that is a point and that is a point. So I'm going to drop down there and drop down there. Now, what are my options? 50.2 looks pretty good because it's below 60. So it could be that one. It could be this one or this one or this one. I don't think it could be that one. But now that I look at the second one, which is over 300, I'm going to cross out that. And now I'm stuck between these two, A or B. But 230 would be somewhere around there, which doesn't fit. So that goes as well. And the correct answer would be B. And so the solution to this equation would just be x is 50.2, or x is 309.8. Now, you could have solved that using trig equation methods I taught you in the last lesson, or visually, you could have just seen that part. Thumbs up if you followed that, thumbs down if you didn't. Okay, fantastic, fantastic. Let's squeeze in a last couple of ones before the break, and then after this, we're going to do strictly old exam questions. So, number one, the graph of y equals tan theta, where theta is between 0 and 360, is not defined for which values of theta? Where is the tan graph undefined, or where we would call asymptotes? If I remember the tan graph from earlier in the lesson, it was 90 and 270. And I do remember it correctly. So a tan graph, if you imagine what it looks like, it has its first asymptotes at 90, and then it has another one at 270, and then the 180 is just in between for when we draw the graph that looks like that. And then on this side we have that. Okay, what about this one? What is the period of this trig function? It's been transformed. What's the period of this trig function? What do we think? Keep those answers coming. I know that this basic sine graph has a period of 360, but I know that the half does something. And what I need to do is I need to divide this by a half, in which case I should get 720. And so my answer is going to be, the period of this graph is going to be 720. Now, I'm not sure all of you have got the period change idea yet. So I'm going to actually make some bonus questions. So I'm going to cross out this one, and I'm going to make my own function. And we are going to say, what is the period of this graph? And I'm going to ask you the same 5 options. What is the period of y equals cos 2x? Which one do you think that's going to be? So the regular period of cos is 360, but we need to divide by that number, and so we get 180. Yeah, that's fine. Okay, one more. What is the period of this function? Tan a half x. What's the period of that graph? The default period of the tan graph is 180. And when we divide it by a half, we should get 360. And so the correct answer would be B. So if you imagine the tan graph being split into 2 halves, each half will get a 180 degrees on the axis. So Tato, yes, for period, the number in front of the x, you will always divide for the period, yeah. That's kind of why I'm taking the time to show you this, because I think a lot of students get caught out. Well, let's even try this question. What's the period, and then we really must take a break. What is the period of y equals 2 cos 3 theta? So Melo, I will deal with that situation in a moment. You're quite right. And I need to raise that before I move on here. So in this situation, all you do is take 360 and divide it by 3 and you get E. But now Klumelo has raised a very important question. What if you get something like this? Say it goes cos 2x minus 30. What are the two transformations that are involved in this particular function? Now, the two transformations here are a vertical shift and a period change. And so if you were given a trig function like this, this is the number that you would divide by. This is the period change number. And then the minus 30 is the horizontal shift. And if you combine a period change with a horizontal shift, then the number isn't exactly next to it. It's just outside the bracket. So Clamelo, just let me know if that answers your question. Okay, cool. All right, it's time for a break. So I want everyone to turn their cameras on, and I want you to, I saw a question come out there. So for that one, it would be 180. Yes, Josh, it would be. For that one, it would be 180. Okay, cameras on. I want to see you standing with me. And we are just going to breathe in. Breathe out. One more. Okay, so you've got some oxygen going through your body. Then let us do some, shake out your arms. Get them loosened up so the circulation is moving. Shake out your legs. And let's just start with some gentle circles with our shoulder blades. And even if it feels a bit silly, just do it, because your body responds to these physical things. Your body has to move stuff around to do these things. And your brain is getting a break too. So just mimic what I'm doing. So smaller circles. And then shake out your arms again. Okay, then arms out in a slide rotation from the hips. And gradually, as you relax, you are going to find that you can go further. Yeah, and then shake out the arms one more time, shake out the legs. And then let's just do some heart rate raising stuff. We're just going to do air skipping. And we're going to do about 20 air skips to just get the blood pumping. Okay, 3, 2, 1. And hopefully your body has had a bit of relaxation, and your brain has had a little bit of TLC. Let's just try and do these two Maths 24 puzzles. So you know the drill. We try and use all 4 numbers to make 24 on each using just one card. See if you can solve them. Who feels like they've got one of these two cards? Okay, so 8 minus 6, Colin, 8 minus 6 gives you 2. So you've used the 6 and the 8. What else do I have to do still to get to 24? Yeah, let's go to Ndabengle. What are you going to do next, Ndabengle?
So times 3 and then times 4.
Yep, you nailed it. 2 times 3 times 4, which would be 24. Well done. Any ideas for the yellow one? I'll give you a bit more time otherwise. Who feels like they can crack the yellow one? Oh, Colin also got that, yeah. Okay, so Bongo Corsi has said 5 over 5 is 1. 1 plus 2 is 3. And 3 times 8 is 24. Yeah, perfect. All right. That is our little bit of Maths 24 for today to give our brain a break. And we're going to head back to our lesson now. Clomelo was asked, would it still be a period change if the number was next to x, like 2x, and not in front of a bracket like this? Okay, as long as the 2, so if you've got your trig function, as long as you've got this situation going on, the moment the 2 is in front of the sign, it's going to be an amplitude change. Okay, but I think maybe if we go to some old exam questions, let's see what it looks like. Okay, let's have a look here. So here is a past paper question, and you're given a cos function, which is f. So let me just put it in yellow so it's clear. And then you're given a sine function, but it has had a transformation. And I'll leave it to you to think about what type of transformation you think it is. But that's, there's been something that's been changed. And then the domain that we're playing in is from minus 180 to 90. So you can see minus 180 here, 90 there. I want you to figure out for me 6.1 and 6.2. See if you can get those two answers. What is B and what is G? Kirsten, that's a hard question to answer. Yeah, we don't normally think about that. You can only ever have a maximum of 2 transformations in a trig question. But yeah. Okay, what is the value of B? Well, first of all, it's a horizontal shift. And to me, it looks like the graph went 30 degrees to the left, in which case, if I want to go to the left, I must have plus 30. And so B is plus 30. Okay, so the graph G of X would be sine X plus 30. What is G going to be? What is the period of G going to be? So the period hasn't actually been changed. So it's whatever the period of the sine graph is, which would be 360 degrees. Okay, so we've done 6.1 and 6.2. Let's look at 6.3. It says, write down the values of x in the interval. Now, the interval is just the same old interval that we started with. It starts at minus 180, it goes to 90, for which this is true. So let's just have a closer look at this. For which f of x minus g of x equals 0. Now, f is just the cos function, the yellow one, and g is just the green one. But the way this is written makes it seem trickier than it really is. What would be an easier way to write f of x minus g of x is 0? What would make it simpler to understand the relationship between f and g? Does anybody have any ideas? Because the difficult part about this question is interpreting what f of x minus g of x means. But if you rewrite this in another way, it makes it easier. Give me a thumbs up if you understand why f of x minus g of x is the same as f of x equals g of x. So give me a thumbs up if you understand that these are the same thing. Okay, now I want you to look at your graph, and I want you to think. You know that f is yellow, and you know that g is green. For which x values is yellow equal to green? Maybe I should even make this. I can definitely see one spot. So where x is equal to 30. Or where else? Oh, what did I just do? I just changed something. Sorry. So x is equal to 30. And then I also think it's when x is equal to minus 150. So that's the place where f of x equals g of x. Okay, awesome. Now, we're really getting into the tougher ones. So the next part says, for which values of x in the interval is the sine of 90 minus x greater than g of x? Now, this sine of 90 minus x seems pretty random. So I want to ask you the same question. Is there a way of rewriting the sine of 90 minus x in a way that possibly makes life easier? What do you know about trig and sine of 90 minus x? How could you rewrite that? Because it feels like it's been dressed up to make it appear more difficult than it really is. I think this is a co-ratio that can be written as the cos of x. And oh my goodness, if I'm saying when is the cos of x greater than g of x, that seems a lot simpler because the cos of x is actually just the graph of g that I mentioned earlier. So in some ways, what this is saying when is f of x greater than g of x? For which x values is that true? Or if I use my colors, when is yellow above green? So I want you to think about what answer would you give for that? When is yellow above green for which x values? So let's look at the graph. It feels to me like yellow is above green from here, and then it stays above green all the way to there. At these points, they're equal, so they're not included. So I'm just going to say x is greater than minus 150, and it's less than 30. And I can't have includes because where the points are equal, I'm not, this says over here, where is it? It's strictly greater than or less than. So I can't include the endpoints. So it's just going to be the purple bit that goes from there to there. Give me a thumbs up if you could follow that. Give me a thumbs down if you didn't. And then I want you to put all your attention to question 6.5 now. Last question, it says, the graph of H is obtained by shifting F, the yellow graph, up by 3. Determine the range of H. So I want you to think about what is the function H? What does it look like? And what would the range of H be? So let me first try and write down what the function H is. So I know it has a cos of x because it comes from f, but then it needs to be plus 3. Now my normal range for cos is that, but now everything needs to add 3 to it to move up by 3. So minus 1 plus 3 is 2, and then 1 plus 3 is going to be 4. Or another way of writing it is y is greater than or equal to 2, and it's less than or equal to 4. Okay, everyone. So if we look at the range question, we first had to build a new function. And this new function was just an old function plus 3. But then we had to think, how did the range change? It used to be that the range was minus 1 to 1. But then because I added 3, I had to add 3 to each of the highest and lowest values in the interval. Okay. Don't know if we have enough time for another question, but it's a little bit too much detail. Okay, let's just do part of this. We're not going to do the whole thing. We're just going to do part of it. So if we look at this graph, we always start by introducing yourself to the functions. So this is the graph of sine, and it has a particular transformation. And this is the graph of tan, which has a transformation, and it's in the domain 0 to 360. I want you to find me the values of A and B. What are the values of A and B? So we know that A is an amplitude change. And so we look at the sine graph, and it looks to me like the sine graph goes between 2 and -2. And normally it would go between 1 and -1. So for me, I think the value of A is 2. And yeah, so it is 2. What about B? What's B going to be? So what does B change? It changes the period. And the old period of the tan graph would be 180. And then you would need to divide by something. And that thing you would divide by is B. What is the new period of this tan graph? What is the new period? It feels to me like this tan graph's period is no longer 180. In fact, normally the asymptotes are at 90. So now that they're at 180, I think that the period here is 360. So what is B going to be? Well, I can get 180 equals 360B. And then I can go, what is 180 over 360? And it's going to be a half. So B is a half. Okay, we've got time for one little bit. Write down the coordinates of P and Q. Can you figure out what the coordinates are with P and Q? Remember, though, you know what the equation of F is now. You've just worked it out. So F of X is 2 sine X, and G of X is tan, open that bracket, a half X. So you can use that. What are the coordinates of P and Q? Where is P? Oh, well, for P, I know that X is 120. And for Q, this, it feels like it's in line with X is 240. But now I need the other coordinate. How am I going to get the Y value here and here? Yeah, you just sub it in. And because it's in line with the intersection points, I would just use the simplest function I could find. And since I'm going to say 2 sine 120 for that one, and then here I'm going to say 2 sine 240. And notice how I'm just subbing in the values that, and so you're going to have to help me with a calculator what you get. For P, it seems like we get 1.73. What do we get for the Y coordinate of Q? So we are going to get, it seems, minus 1.73.